Okay, the question before us says a projectile is launched with a speed of 50 meters per second at an angle of 40 degrees above the horizontal. Ignoring the effects of air resistance, determine the maximum height, each horizontal range, the displacement, velocity of the projectile 2 seconds after it is launched, the time taken when it is 40 meters above the projection. So let's start. So to answer this question, let's first draw what and find out what case it is. I normally tell you classify projectile as case. Projectile is that type of motion that happens at the x and y axis, and when it's happening at y axis, x does not know anything about it, and when it's happening at x axis, y does not have any business with it. So notice it moves at an angle of 40 degrees, and then it must come to the ground. It moves with an initial velocity of 50 meters per second. So this is case 1, when it is projected at an angle above the horizontal. So to find my h, which is a, h will simply be u squared sine squared theta all over 2g. So all things being equal, being done well, I will simply calculate by putting the value I'm giving. I'm giving speed of 50 meters per second, meter per second at an angle of 40 degrees above the horizontal. So I'll simply have here to be 50 square sine square 40 all over 2 times 9.8, which is the sentinel saying 25 times 0.41317. Punch your own. I know use calculator, so punch those. So this should give me, which is approximately 53 meters. So this is approximately 53 meters for the maximum height. And for the range, we know that range talks about the total horizontal distance. So in this case, as it's moving from here, this is displacement s. If it's going in this direction, it's positive displacement. If it's coming down, it's negative displacement. So as it's going in this direction, s becomes r. So our range is going to be calculated using the case 1 method of calculating range, which is equals to u squared sine 2 theta all over g. So once you see this kind of case, just know that all the formulas of projectile motion works for it. So you don't need to think extra. That is, in this case, the theta is 40 degrees. And this is approximately 251. Okay, when you divide, you get 251.23 meters. That is for the range. And it says the displacement. Before I can talk of displacement, let me find the total time of flight. Which is t, and that is given by 2u sine theta. We've discovered all these things. If you don't know how to get it, go and check my video on projectile motion. So this is going to the sentinel saying 2 into 50 sine 40 degrees all over 9.8. and this is going to be the sentinel as in 100 sine 14 all over 100 sine shebi wait 100 sine 14 all over 9.8, which is equals to 64.2788 all over 9.8, which is equals to 6.5591 seconds. So this is approximately 7 seconds. Okay, so now they asked us to find the range, which is the displacement, which is the C part, the CI part. This is the question. They say we should find the displacement. So we know that displacement from S, that is our UT, that is S equals to UT plus half AT square. So if I'm to find the displacement here, I'm going to be checking everything I reached. So S will simply be the sentinel saying 15, then the time it took to cover the whole flight, everything, we got it to be what is it called? We got, okay, we are not given time. We are not given time, but we've gotten the total time. And if we've gotten the total, notice that if I choose to say here, if I choose to find from this point to this point, and this point to this point, this is what we call range, the total horizontal distance, horizontal displacement. But since they said displacement of the projectile, that is both on the vertical axis and on the horizontal axis, they want me to find the displacement that happened here, everything that happened here. So if I'm to find everything that happened here in this projectile motion, all I need to check is, what did I get as my range? I got 251.23. That is my total horizontal displacement. Now let's check on the vertical axis. Do we know anything about the heights? Yes, and the maximum height is 53 meters. So I think the best way we can go to this is to simply say, let's make use of the total displacement, then multiply it by time. That is the total time that we got. So if we do that, so this is like saying the horizontal distance, the horizontal displacement plus the vertical displacement. So this is going to be 50 times 6.5591, which will give me 327.96, then plus, because I know that on the vertical axis is going to be gravity, the going up, and this will change to gravity, the going up, and this will change to minus the going up. As it's going up, it's going to be minus because the G will be against gravity. Then, and the time taken. So I will now have, that is the time to go up, sorry. So this is now going to be the sentinel saying, notice that what I use for this vertical is initial velocity and total time taken. Why this one was going to be half minus half G, and time to go up is given by U sine theta all over G. So this is what I'm going to use for this side. So when I do this, I should get everything for my vertical side, then add it together. That's my displacement. So I now have, this is the same thing as saying 50 sine 40 all over 9.8. So let's punch it and see what we have. This is going to give me 32.1394 all over 9.8, and when I punch this, it should give me 3.27953. Yeah, then remember that everything here is going to be squared because the t is squared, so everything here is going to be squared, then times g, which is 9.8 minus 9.8 over 2. So take the square. So let's do the square. Let's take the square. And this should give me, everything inside the bracket should give me 10.7553. That is when I square it. Then remember that I have minus 9.8 divided by 2. So let me do it. If I do 9.8 divided by 2, I have 4.9. So I have minus 4.9. So if I choose to, I'm trying to solve this part first because this is the part. It's more like displacement. The total displacement of the projectile is horizontal displacement plus vertical displacement, but by the time you add it, because the vertical is going up, it will have minus sign. So I will simply do 4.9 times 10.7553. So if I do 4.9 minus 4.9 times 10.7553, I should have minus 52.797. So remember, I got the product, I got everything for this to be 327.96. So the displacement S will be equals to everything here minus everything here. So I would now have 327. I'll have 327. I have 327.96 minus, okay, let's punch it, minus 52.797. I'll have 327.96 minus 52. So I have 275.25903, which is approximately 275.3 meter. This is the displacement. So this is the displacement. That is the displacement of the projectile motion. This is it. So it is equals to S is equals to displacement on the horizontal axis, because horizontal axis will not have the other side. So it's equals to displacement on the horizontal axis, plus minus half gt square. That is displacement on the vertical axis. Yes, it's displacement on the vertical axis or on the y component, because when it's coming down, as it's coming down, as it's launched and coming down, the u of the vertical component changes to 0. So as it changes to 0, notice that it's first launched up, and as it changes to 0 when it's coming down, it will not have this side. So by the time you add these two up, and notice that this one is going to carry that minus to show that the g is going up against gravity. So by the time you add it up, you get the displacement of the projectile. So then they asked us to find something in that question. The D part says the velocity of the projectile 2 seconds after it is launched. Sorry, the CII part, it says the velocity of the projectile 2 seconds after it is launched. So let's find that. And I've told you before that anytime you want to find something that has to do with when it's launched, okay, let's say this is CII, let's solve it. Find the velocity of the projectile 2 seconds after it is launched. So let's say this is the horizontal. It is launched. As it's going up, once it gets to the maximum height, the v will be equals to 0. So but let's say this is like 2 seconds after it is launched, t at 2s. So as it's going up, it has a velocity that is carrying it up. So this is the velocity here that they're asking us to find. So that means that if it's going up, and I've told you anything that has to do with maximum height, when it's still going up, you get it from v equals to, that is the time for maximum height, you get it from v equals to u plus at, and this time g will be there because for gravity, then you have minus u. So to get this velocity, simply remember that this is 50 minus g is 9.8, then t, so, and remember they said t at 2 seconds, velocity in 2 seconds, so this t will become 2. So this is going to be 50 minus 19.6, so that v will be equals to 30.4 meter per second. So this is the velocity. So the D part asked us to find time taken when it is 40 meters above the ground. So the last part for number 1 says the time taken when it is 40 meters above the projection level. So the time taken, because they gave me 40 meters above, that is the height is 40 meters. So for that reason, I will make use of, and they are asking me for time, I will make use of s equals to ut plus half at squared. So notice here, this will change to h, and this is equals to 40 equals to above. Since it's still above, notice that if this is like the projectile, and they said it's 40 above, that means it's when it's still going up, because 40 meters above, if assuming it goes this way, since it's going this way, if it's coming down this way, it should be negative 40. So it is when it is in this side, displacement is, or the height is still when it's this side. So as it's going this way, that means it's still carrying that is u, which is 50. Then the time is what they're asking us, the t plus half, then it's still going up, this will be minus g, then t squared. So, and you know that g here is 9.8. So I just want to put everything out so that you understand. So now let's try to make t subject of the formula, right? Let's bring this out. Let's make the t subject of the formula there first. So I have h is equals to ut minus half or gt squared, and this is the same thing as saying h equals to ut minus gt squared over 2. So anything over on this one is over 1. So if you do this very well, you see that these are fractions. So then that means nothing is getting cancelled out here. You're making subject of from, so 2 into this becomes 2 ut minus this will get out, so you have minus gt squared equals to 2h. Then 2h is equals to 2ut minus gt square. So if I take this to cross equality sign, it's the same thing as saying at this point I can do cross equality sign. Let the ones with 2 come together. So I have 2h minus 2ut equals to minus gt square. This can cancel this thing. So that I now have 2h minus 2u equals to minus gt. I'm making g such a form this can divide all over. So this is what I'm going to use. So t minus t, and you know that if it's minus t, I can carry this minus. I can say divide both sides by minus so that the minus comes here. So it's the same thing as saying minus t is equals to 2h minus 2u all over g. So this is what we will use to solve. So let's go and put it there. So I'll simply say 2 into h here is 40. Then minus 2u, u is 50, all over 9.8. So I know that this is going to give me 80 minus 100 all over 9.8. This is going to give me, that is t minus t. You remember? See, remember now? Minus t is equals to this. So minus t is equals to, minus t is equals to minus 20 over 9.8. There is minus here, there is minus here. Minus cancel minus. T is equals to 20 over 9.8, which should give you 2.04. And t is approximately 2 seconds. So that is it. So at the point where you have the height to be 40 meter, the t is equals to 2 seconds. So let's move to question 2. Let's move to question 2. Let's move to question 2. So for question 2, they said an object is projected upwards. Question 2. An object is projected upwards at an angle of 30 degrees to the horizontal from the top of a tower of height 100 meters. So let's just analyze first question 2. Let's say this is the horizontal. Then they say that there is an object that is at the top of a tower. First thing is to understand this projectile motion. Before you start tackling the question, you'll be checking which case it is. It is a case of when you have a projectile above the projected above at height above the horizontal plane at an angle. So let's say the object is a ball. Now it is projected at from this point 30 degrees. So I'll just come and put all my dash. So this is case 2, 30 degrees. An object is projected upwards at an angle of 30 degrees to the horizontal from the top of a tower. That is, this is the tower, and this tower is 100 meters high. And it hits the ground at point Q. So it now hits the ground at point Q. This is the ground level. They are now asking us, and then if the initial velocity was 100 meters per second, so this is the initial velocity, u equals to 100. Then remember that from this point to this point is the range, the horizontal distance, r range. We say horizontal displacement. So they are asking us to calculate the maximum height of the objects above the ground. Maximum height, that is from this end to this end, then to this end. That's what they're asking us to calculate. So everything here. So notice that everything on this section looks like your normal projectile case 1. Then you have an extra height, which is 100 meter here. This is 100 meter. Already, you know this height. So what you just need to do is to find this particular height. When you find it, you add the 2 up. So, and to find this one that looks like your normal projectile, you do it using maximum height equation, which is h equals to u square sine square theta all over 2g. So all I need to do is to say 100 square sine square 30 all over 2 into 9.8. I think I'll start using 10. It's 9.8.